do a demonstration to help figure out, to show and figure out what this actually looks like. Now I have a triangle over here, and I have two sides. So as we normally do, let's label our sides. So I've got my right angle here. I've got my hypotenuse over here. So 20 is my hypotenuse. I've got my angle here, and I've got my opposite side. So my opposite side is over here. That's the 10. And here my final side is my adjacent. Now, as you notice, I've got the O and H will give me sine. So I've already set this up here. Now, if you remember, when we're doing trig, we are going to write, we put in our angle. So on the left-hand side, where I have sine, my input is going to be sine 30 degrees. Now, if you remember, when we were doing sine 30 degrees, that's just opposite over hypotenuse. And so for this triangle, what I'm going to write is 10 over 20. Now, if you remember, you can actually put sine 30 into a calculator, so we can actually check that. So I'm going to put sine 30 into a calculator, and that actually gives me 1 over 2. Now, if you have a look at the fraction that I've got 10 over 20. It's not quite 1 over 2, but actually it is the exact same as 1 over 2. We can actually simplify 10 over 20, and that will get me, if I cancel out the zeros at the end, so divide both the numerator and denominator by 10, I end up getting 1 over 2. Which is exactly what I had on my calculator. Sine 30 is 1 over 2. Okay, now, what inverse trig does is we take our ratio and it gives us back the original angle. So let's have a look at this. I'm going to, instead of doing, on the right hand side I have sine inverse sine, and instead of putting in an angle, so I'm not, over here, you do not want to put 30. You are not going to put 30 into inverse trig. Instead of putting 30, I'm actually going to put the ratio that I have in my triangle. So if you have a look, I'm going to put O over H. So just remember, sine theta is equal to O over H. So sine inverse O over H will give you your angle. So here, I'm going to put in O over H. So in my triangle, I had O is 10 and H is 20. And that should hypothetically give me 30 degrees. So let's put that in my calculator. Let me do that. So I'm going to go shift sine 10 over 20, and I'm going to close the brackets. And look, we get 30, our original angle. So here, this is just to show you that this is exactly how it works exactly like we wanted it to. Regular sine, we put in angles and we get a ratio. Inverse trig, regular trig, we put in an angle and we get a ratio. So for example, sine 30 is equal to a half. But inverse trig, we put in a ratio and we get the angle. So here we have, inverse 10 over 20, which was the ratio that I had, O over H, and that gave me 30 degrees. So that's how we can use inverse trig to help us find missing angles. So what I'm going to do